Today we are going to discuss about the design thinking approach, which is based on the semiconductor material, which is our PN junction diode. As the SNS institution, we are following the design thinking approach, which is in the 5 stages. Will be the empathy part, define, ideate, and prototype, and test part will be there. And taking the DT part of PN junction diode, the PN junction diode, which is evolved from the semiconductor material. The semiconductor material, which is known with, will be partially conducting, which is where energy band gap will be low for the semiconductor material. And in the semiconductor, there will be having two types, which is intrinsic and extrinsic type will be there. The intrinsic, which is the purest form of semiconductor, and adding some impurities, it is named as the extrinsic type of semiconductor. In the extrinsic only, we are classified into two types, which is P and N. And adding the pentavalent and trivalent impurity, the material will be classified on P type material and N type material. And coming to the PN junction, we are taking P type material as well as N type material and combining together, it is forming junction, so it is called PN junction diode. Mostly the diode, the name which represents, it is conducting in only one direction. So mainly the diode will be used as rectifier as well as clipper circuit as well as in a clamper circuit in our household appliances also we can use. The main purpose of the diode is it will be acting as a switch. And also for rectifier, it is converting the AC circuit as well, converting the AC into the DC circuits. In many applications and for transformer or any application, we are using this basic PN junction diode. Now we can take the topic of PN junction diode. We can elaborately discuss this topic in each stages and we can conclude our PN junction diode.
So as the first stage is empathize. So empathize means understanding the user needs. So why we need semiconductor? Because what is semiconductor? Semiconductor means it is the ability to conduct electricity, which is like with the conductor and an insulator. Conductor means, for example, a copper. Insulator means you can take a rubber as an example. So these both insulator and semiconductor, which is called insulator and conductor is called semiconductor. So there are two types of semiconductor, which is intrinsic semiconductor and extrinsic semiconductor. So in intrinsic semiconductor means we add there is no impurities, which would be pure. For example, pure silicon. So if we come to extrinsic means we add some impurities. So this is called extrinsic semiconductor. For there are two types of extrinsic semiconductor. One is P type semiconductor, P type and N type. So why we need this means, so if we take an electronic items like electronic components, they work in AC and DC both. So for in DC circuits, they flow in one direction, only one direction. But in AC, we want to take like, so if we take DC means the current flow will be, for some sensitive components it will be drawback. So we need DC circuit for that. So engineers ask questions why this happens in DC circuit. So we need some problems answer for this. So we go to PN junction diode. This was the empathize part here.
Now I am going to discuss about the defined part. What is a PN junction? A PN junction is formed by joining two specially doped semiconductor region. One is P type, which has excessive holes, and other is N type, which has excessive electrons. When these two meet, some electrons and holes recombine, forming a depletion region. This depletion region acts as an internal barrier. This built-in barrier prevents current from flowing through it, and it is overcome only when external voltage overcomes it.
When the external voltage is applied to our junction.
And this acts as a foundation for a diode. So in the ideal stage, we are thinking about the different ways we can connect the PN junction diode. So here we think of the two types of the junction diode. The PN junction diode does not behave the same in every situation. It depends upon the external voltage we are giving. So here we think about two types of bias, the forward bias and the reverse bias. In the forward bias, when the positive terminal is connected to the P side and the negative terminal is connected to the N side, so it results in that barrier region will be reduced, so the current flow will be easy. In the reverse bias, it is the changing the terminals. So if we
Negative terminal.
if we connect the positive terminal to the N side and the negative terminal to the P side, here the barrier region will
Narrow.
Will become larger.
Will become larger.
so the current flow will be
Low.
and reduced.
For the next step, we'll go to the prototype step. From what she said, we know that the forward bias and reverse bias definition. Forward bias is that we are connected to the positive and positive terminal, and the reverse bias is that we are connecting the negative and positive terminals. So the interchange of terminals are which defines forward and reverse bias. And from what she said, the depletion region also defines from the forward bias and the reverse bias, where the forward bias the depletion there becomes narrow, and the reverse bias the depletion becomes bigger. So from this we can get the IV characteristics graph, which is the current and voltage graph. From this graph we can see the forward bias. Here the forward bias takes place where the graph starts. As from the definitions and all, we conclude to VI graph, that is the current and voltage graph. And from this we could see that the voltage starts from the fourth quadrant to the first quadrant. Here the voltage comes from the down to where the minimum knee voltage, which is the knee voltage is the minimum voltage which requires to. Now everyone we know that the graph is VI characteristic graph, that is the current and voltage graph, and we come to the concluded topic in this forward and reverse bias. Here the forward bias takes place and the reverse bias takes place here. Here the voltage comes from the lower fourth quadrant to the first quadrant, where this is the knee voltage. Knee voltage is nothing but the minimum voltage which is required for the current to flow. From when this point becomes, when in this point the current flows like extremely fast, and at this point we could see the minimum value of silicon diode is 0.7. For this here, diode acts as an open circuit, where this point acts as breakdown voltage, where here reverse bias takes place. That's it, the VI characteristic graph.
Finally, the test stage. The diodes tested in real life use. They have changed AC to DC in rectifiers, shape signals in clipper and clamper circuits, and protect the device from wrong battery connections. You can see the diodes in chargers, radios, power supply, sensor, and LED drivers. So even though the PN diode is a small and simple part, it is very important in electronic devices, and it is used in every electronic device we use today.
Okay, thank you for the discussion what we have discussed about the DET stages. At last, we came to know about the PN junction working principle and what are the VA characteristics as where the PN junction is used in rectifier, flipper, clamper circuits, as well as in day-to-day life we are using our PN junction diode. Okay, thank you students for the discussion.
Thank you, ma'am.